Hello everyone. Welcome to the solution of LeetCode problem 2685 named Count the number of complete components. In this problem, we are given a undirected graph of n vertices numbered from 0 to n-1 and a two-dimensional integer array where each entry is a and b denotes that there exists an undirected edge connecting vertices ai and bi. Now we have to return the number of complete connected components of the graph. Here, a connected component is a subgraph of a graph in which there exists a path between every two vertices or every two nodes, and no vertex of the subgraph shares an edge with a vertex outside the graph. So here, a connected component is said to be complete if there exists an edge between every pair of its vertices. Now let's consider this example. There are three subgraphs, which is 5, another is 0, 1, 2, another is 3 and 4. So here we can see that this single node 5 is complete because it does not have any of the edges. This node 0, 1, 2, this 3 node is a part of the complete graph because we can go from any node to any other node, or we can say that any node has direct connection to the other node. Suppose for this node 2, it has direct connection of 1 and 0. For this node 0, it has direct connection 1 and 2. And for this node 1, it has direct connection of 0 and 2. Now, for this 3 and 4, 3 has a direct connection with 4 and 4 has a direct connection with 3. So we can say that for these scenarios, the number of complete component is 3, so we have to return 3. But here, in this second scenario, so we can see that the second graph, which is 5, 3, 4, is not complete because there are no path between 5 and 4. So here the number of complete component is 1. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken this example, which is similar to the first example. Now, how can we solve this problem? Basically, the first intuition is there is an undirected edges. That means, suppose for this edge between 1 and 2, undirected edge basically means there are two edges. One is 1 to 2, another is 2 to 1. For this 2 to 3, there is an edge 2 to 3 and there is an edge 3 to 2. Similarly, for this 1 and 3, there is an edge between 1 and 3 and there is an edge between 3 and 1. So here, one undirected edge means basically there are two connections, one from the first node to the second node, another is the second node to the first node. This is the first intuition. And if a graph is complete, that means every possible node is connected to each other. So here we can say that the number of nodes, which is n into n minus 1 is equal to the number of edges. So here, let's see in this middle graph. So here the number of edges is 6, which is equal to the number of node, which is 3 into 3 minus 1, which is 2. So here we can say that the number of node into number of node minus 1 is equal to the number of edges. Now the intuition is very simple. For each of the subgraphs, we have to calculate how many edges we can get and how many numbers of node we can get. And here, if the number of node into number of node minus 1 is equal to edges, we have to consider this as a complete component. Now, as we are given undirected edges, so for each of the edges, we have to consider it 2 times. And after considering the edge 2 times, if the number of node into number of node minus 1 is equal to number of edges for a subgraph, we can consider it as a complete. Now, you have understood how this subgraph is completed. Now, for this subgraph 4 and 6, the number of node is 2 into 2 minus 1 is equal to the number of edges. So we will consider this edge 2 times. So number of edges will be 1 into 2. So here it will be 2 into 1 is equal to 2. That means 2 is equal to 2. So here we can see that for this subgraph also, the number of node into number of node minus 1 is equal to the number of edges. I hope you understood the algorithm, and we will simply do it by using the DFS. And the overall time complexity of this algorithm will be big O of n, which is a linear time complexity. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named count complete components, which has integer n and a vector of edges as a parameter. Now, we are declaring an adjacency matrix, adjacency list, and a visited array to store which node is visited or not. Now, initially, we are given an answer. Now, we have to iterate for each of the edges and make the adjacency list here. For adjacency of x, we will insert y, and adjacency of y, we will insert x. Now, for each of the node, we have to check whether the current node is not visited or not. If the current node is not visited, we have to start the DFS function. And inside the DFS function, we will pass the adjacency list, visited array, current node, and the number of node and the number of edges of the current iteration as a parameter. And here in the current iteration, the number of nodes and the number of edges initialized with 0. After that, in the DFS function, we have to make the visited node. So insert the value 1 into the visited of node and count the node counter. For each of the child in the adjacency list of node, we have to increment the edges because the number of child denotes the number of edges. And if the current child is not visited, again, we have to recursively call the DFS function with this child with the rest of the similar parameter. Now, after completing the DFS function, if the number of nodes into number of nodes minus 1 is equal to number of edges, we have to increment the answer. And here, we have to consider that for each of the edges, we are considering each of the edges 2 times. So, that means if this condition is true, we have to increment the answer. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.